In today's lesson, we're going to be learning about the structure of a proof. Now, as you may have noticed, I'm going to be typing out this lesson so you don't need to deal with my really bad handwriting. All right, to start out, we need to define a theorem. So a theorem is a statement that has been proven to be true. The way you prove something to be true is by using definitions and postulates. So we use definitions and postulates to prove our theorems. Both of these things are assumptions. So we start out with our assumptions, which are our definitions and postulates. We start with those, and by following a chain of logic, we prove something that we didn't have before. Now, before we move forward, proofs. Before we move forward with showing a proof and actually doing them ourselves, we need to come up with what the structure of a proof is. So I'm going to start out by describing the structure of a proof, and then we'll describe the proper relationship between the different parts of a proof. So start with learning the structure of a proof. Okay, so first we have what is called the given. A proof always begins with the given, and that is the subject, the thing that we're talking about of the proof. So this is the thing that we're talking about in the proof. The given is our subject of our proof, and it's what we start out with. So, for example, if I want to prove that the sum of the angles of a triangle ABC, that's the name of the triangle, is 180 degrees, then the given, oh my goodness, is just that triangle ABC. Now, the next part is, so maybe I'll start by numbering these things. 1, the given is the first part of our proof. The second part is the conclusion. This is what we're going to end up with. So in our previous example, we were talking about, okay, well, I want to prove that the sum of the angles of a triangle is 180 degrees. So my given was that I had a triangle ABC, and I want to prove that the sum of those angles is 180 degrees. So the conclusion is what we want to prove about the given. Maybe I'll make a capital G there. And in this case, over here, it would be that we're looking at, we want to prove that the sum of the angles is 180 degrees. That would be our conclusion of our proof. The other part that maybe should be 2, but the other part is a diagram. So pretty much all of our proofs are going to include a diagram. That means some drawing. And when we're using a diagram, we are going to label the different parts. And we'll see an example of what that means later. Also, the parts that we label, we're going to refer to those parts within our given and conclusion. All right, let's take a look at an example. So, the example, we're going to try to prove that the sum of the angles of a triangle is 180 degrees. Okay, so let me move my keyboard over here, and we will take a look at the table. So, where are we? Webcam, boom. All right. Prove that the sum of the angles in a triangle add up to 360 degrees. Well, first I'm going to start with my diagram, and I'm just going to write out the given and what I want to prove. That's all we're looking at today. It's just this structure. So a diagram would be, all right, well, I'm just going to draw that picture out. I'm going to draw out this triangle, and I will label it triangle A, B, C, and I'm also going to label the angles in here. So I'm going to label it angle 1, 2, and 3, going with A, B, and C. 1, 2, and 3. All right, well, the given is just triangle A, B, C, or I could have written it out as just triangle A, B, C if I didn't want to write out that whole word. And I want to prove, well, I want to prove that the angles that are inside of this all add up to, sorry, here I have written as 360 degrees. The original in our example that we're looking at here is 180 degrees. So I'm switching that back to 180 degrees there. All right, well, if I want to write this out, I could write out in a sentence, prove that I want to have the angles add up to 180 degrees, but let's try and write it in a more mathy way. So I'm going to write it as, well, I labeled my angles, so I'll write it the measure of angle 1 plus the measure of angle 2, measure of angle 1, measure of angle 2, plus the measure of angle 3 adds up to equal 180 degrees. This is the setup for our proof. We're not proving this yet, but being able to do the setup and to make the diagram and then reference that diagram in our given and our proof part, or our conclusion, I could say prove or conclusion here, that's what we're looking at for today. And that's it. Let's take a look at a second example. So I'll move back to the monitor and let's type this one out. So let's try to set up the proof for this example. Example 2. Suppose that we are asked to prove that vertical angles are always equal. So try setting up that proof, and by using a diagram and a given and a prove or a conclusion section. All right, let's take a look at how to do that one together. So suppose that we're asked to prove that vertical angles are always equal. First, I need to draw my diagram out. Diagram. Well, vertical angles, let me just write the statement out again. Prove that vertical angles are equal. So my diagram is going to be a set of vertical angles. I'll draw these two lines, and now I have 1, 2, 3, 4. These are the names of my angles. Angle 1 is here, angle 2, angle 3, angle 4. And I want to prove, well, that angles 1 and 3 are equal, and that angles 2 and 4 are equal. My given is just a set, or actually 2 sets of vertical angles. And those sets are 1, 3 is one set of the vertical angles, and then 2, 4 is my next set of vertical angles. And what I want to prove, what I want to conclude, is that the measure of angle 1 is equal to the measure of angle 3, and that the the measure of angle 2 is equal to the measure of angle 4. This is the setup for our proof. This is all we need to worry about for this lesson, is just saying, all right, if I want to prove that vertical angles are equal, I need to be able to draw out what vertical angles are, say what I'm starting out with. So a set of two vertical angles, angles 1, 3, and 2, 4. Maybe I should put that little angle symbol next to each of those. And then just say what I'm trying to prove. All right. Now, after that, after we've made our statement, we've figured out our given conclusion, we've drawn a diagram, what do we need to do next? Well, so after we have set up our proof, draw a diagram, and then determine the given and conclusion, or the prove part. So after we have set up our proof, which means drawing our diagram, determining the given and the conclusion, well, then we need to prove it. A proof will consist, means that it'll be made up of a set of statements that ends with the conclusion. Now, any set of statements won't do. We need to use a specific set of statements. We need to start with our given and make a bunch of statements that are all true, that going from one statement to the next lead to our proof. We need to start with our given, then go from that using only true statements, which come from our definitions, our postulates, and other things that we've already proven. So I start out with a given, and then I use definitions, postulates, and other things that I've already proven, and I just keep going along a trail until I get to my conclusion. Now, a really important thing is that a proof is 100% guaranteed. A proof is completely guaranteed. I think I spelled that right. Spelling error. So, and we're guaranteed because our given starts out true. All of the statements that we use, and we go from statement to statement, are also going to be true. And if we follow along that path and are able to reach our conclusion, that means that our conclusion must be true. And that's it. You just start with something that's true, which is your given. You go along a couple of sets of ideas that are your statements, and as long as those are all true and we get to our conclusion by the end, you've made a proof. Now, if you start with a given that is not true, then it's not going to work out. You can prove anything you want if you start out with something that's false, and maybe we'll get a chance to see an example of that at some point. Also, if any of your statements on the way are not true, then your proof is not correct. So that was an introduction to the structure of a proof. Hopefully we'll have enough time, and we're going to keep moving forward, and we're going to get to actually completely proving something.